Okay, this is the second part of the notes. I thought I had recorded everything, but the board was starting to not work properly, so um, here we go. Talking about combining expressions when you have uh, multiplication and division with some roots. So for number 7, because it is a multiplication of two cube roots, I'm just going to put them into a single cube root. 2 times 12 is 24. X to the 4th times x to the 5th is x to the 9th. Now I'm going to break this up thinking about cube roots. So the cubed root, 24 is 8 times 3. 8 is a perfect cube. X to the 9th is a perfect cube. It's x cubed cubed. So now the cube root of 8 is 2. The cube root of x cubed to the third power is just x cubed. But I'm left with that factor of 3 still inside the cube root. Nothing can be done with that one. So that stays like this. Okay? Doing the same thing as simplifying the square roots, but not looking at perfect squares, I'm looking at perfect cubes. For this bottom example, I'm going to do the same thing. We're dividing two cube roots, so I'm going to put them into one giant cube root. Now I'm just dealing with the similar objects. 625 divided by 5. That's 125. X to the 12th divided by x squared is x to the 10th of our rules of exponents. Top exponent minus the bottom exponent. Y to the 16th divided by y to the 4th, that is a y to the 12th. Okay, so now, cube root of 125, that's 5. Let's just keep on going with this thought process. Cube root, 125 is 5 cubed. Now, this x to the 10th, x to the 9th is a perfect squared. There's an extra factor of x, or it's not a perfect square, but a perfect cube. For y to the 12th, that is y to the 4th to the third power. So it is also a perfect cube. I'm going to rewrite this x to the 9th. Maybe. There we go. That x to the 9th is x cubed to the third power. So now I break this up because it's multiplication there, there, and there. Cube root of 5 cubed is 5. Cube root of x to the third power raised to the third power again is just that x cubed. The cube root of y to the 4th that's raised to the third power is just y to the 4th. Now, I've accounted for this, this, and this. There is a factor of x left over inside of that cube root. We can't just forget about it, so it stays inside there. And that's our answer for that one. Okay, you can try these other two examples, 8 and 10, if you want, and check. You can just have me check it when you come into class. All right, to add or subtract with the radicals, you think in like terms. You can only add and subtract like terms. What makes radical like terms is that it's the square root of the exact same number. So, simplify those radicals. The square root of 12. Well, 12 is 4 times 3, so square root of 4 is 2. So this is 6 plus 2 square root 3. We are adding square root of 75. 75 is 25 times 3. So we're looking at negative 7. Square root of 25 is 5. Square root 3. Okay, so now we have the same square root. So we're just adding like terms. The real number, 6 plus a negative 7. That's a negative 1. Once you have the square root of the same number, it's just like adding x's. You've got 2 of these square root 3's. We are adding 5 of those square root 3's. That gives us 7 of those square root 3's. Okay? That's how you do these. So this next example, same thing. Let's simplify those square root of 18 and square root of 50. That's 9 times 2. This is 25 times 2. So we're looking at negative 5 minus 3 root 2 minus 6 plus 5 root 2. And now, like terms, negative 5 minus 6 is a negative 11. We have negative 3 square root 2's. We are subtracting 5 of them. That means we have a negative 8 square root 2. And that is it. Because that negative 11 does not have a square root with it. It is not a like term with the 8 square root 2. So we just leave them separate. Okay, this is multiplication. It's FOIL in between there. Or it's multiplication between the two parentheses, so it's just FOIL. The first term is multiplied together. So 2 times negative 3 is a negative 6. Square root of 5 times square root of 5, that's a square root of 25, which is just 5. So I got a negative 6 times 5, which is a negative 30. All right, we're going to do the inside terms. I don't know if I'm spelling FOIL right or not, but we got to do the inside terms anyways. 3 times negative 3 is a minus 9. Square root of 7 times square root of 5 is the square root of 35. We can only do that because it's a multiplication. The last terms, the outside terms. 2 times a negative 6 is a negative 12. Square root of 5 times square root of 7 is square root 35. And now the last terms gives us a minus 18 times 7. Square root of 18 times 7, that's 70 plus a 56, so 126. Now, these inside terms combined, they're the square root of 35s. Those are like terms. We've got a negative 9. We're subtracting 12 of them. That's a minus 21, square root 35s. Negative 30 minus the 126 is a negative 156 minus the 21, square root 35. That's all we can do to simplify this one. So it's just FOIL, essentially. All right, the last bit for this section is rationalizing the denominator. You look at these two examples. It's considered poor mathematics. It's not proper mathematics to leave a square root in a denominator. And so proper mathematics says you got to get rid of it. So depending on what your denominator is, if there's a square root in it, you need to do something. For this first example, number 17, we have 6 over 3 square root 5. What we're going to do is multiply top and bottom by that radical, square root 5. Again, square root 5 over square root 5 is just 1, so we're multiplying by 1. So we're not changing our value. We're just making this fraction look different. So when you multiply fractions, you go straight across. We got 6 square root 5 over 3 times square root of 5 times square root of 5 is the square root of 25, which is 5. Now, the 6 and 3 have a common factor of 3, so what we're looking at is 2 square root 5 over 5. Okay? No more square root in the denominator. That's a proper fraction. Okay? For example number 18, what we are going to do is multiply by, I think we've done these problems before. You're going to multiply by the conjugate of that denominator. So square root of 5 plus 6, top and bottom. Okay, that's square root of 5. We can't have that anymore. So to get rid of it, it's not enough just to multiply by the square root of 5, because then we'd just be having a term of a minus 6 square root of 5. So multiplying by the conjugate is going to cancel out all of those radicals in the denominator. So to do this problem, the fractions, we just multiply straight across. So we got 5 square root 5, and then a plus 30. In the denominator, it's really the difference of squares pattern. Square root of 5 times square root of 5 is 5. The inside terms is going to be a negative 6 square root of 5. The outside terms is a positive 6 square root of 5. Those cancel out. Minus 36 from the last terms. So we have, I'm going to put this number first, 30 plus 5 square root 5 over our denominator is a negative 31. Again, no more radical in the denominator. That problem's done. All right. So that is all of it for this chapter, or sorry, not this chapter, but this section. Have a good night.